In today's world, we live in a throwaway culture, run by the attitude that it is easier to throw things away than to fix them. And at the center of our throwaway culture are single-use plastics. We are creating products that are designed with the intention of being disposed of quickly. In fact, according to Five Geyers Institute, plastic bags have an average working life of just 12 minutes before being thrown out, ending up in landfills and oceans where they have a life expectancy of 10 to 1,000 years before decomposing naturally. The plastics we are using for just moments are creating impacts that will last for decades. Single-use plastics like plastic bags and containers have brought convenience to our society. They are cheap, durable, and readily available to the masses. But we must stop and think of the inconvenient consequences that emerge from this culture of convenience. Throughout the different stages of the plastic cycle, from the time that it is developed to when it is decomposed, ecosystems and local communities are impacted, posing harm to marine and terrestrial wildlife. And in Canada alone, people living in areas where plastic accumulates, is produced, or is incinerated are susceptible to increased risks of cancer, water poisoning, and toxic air emissions. Research has shown that these demographics consist of Indigenous groups, Black Canadians, and those of low socioeconomic status. Furthermore, nearly every stage of the plastic cycle results in the release of greenhouse gases, exacerbating climate change in the process. Fossil fuels are needed in creating plastics, refining them, and carbon emissions are then released in the production process and incineration. Plastics are in every aspect of the word an unsustainable product, produced through unsustainable means. It has become clear that our attitudes as a society toward throwaway culture needs to change if we want to enhance both environmental and social sustainability. Now the question becomes, can both the problems of plastic pollution and resulting carbon pollution be addressed? We are Rhs Calgary, and we think that we have the solution. As a team of 24 passionate junior high and high school students, to combat the problems of plastic pollution and carbon emissions, we present our solution, BioCapture. Our project aims to transform atmospheric carbon emissions into viable bioplastic solutions, utilizing genetic engineering in order to replace traditional single-use plastics. Through this, we would be addressing two United Nations Sustainable Development Goals, number 11, Sustainable Cities and Communities, and number 12, Responsible Consumption and Production. Our proposed solution can be broken down into three primary objectives, or what we like to call our 3 C's: capture, convert, and create. In order to achieve these objectives, we were inspired by the biohybrid system developed by Lim et al. In 2023, composed of an electrolyzer and a fermenter. In this system, an electrolyzing chamber takes atmospheric carbon and converts it into formate. The formate is then shuttled into the fermenter and is taken up by the Cuprovitus necatar H15 strain. This bacterium can create polyhydroxybutyrate, PHB, a biodegradable polymer that can be transformed into viable bioplastics. At this phase of ideation, we are thinking about forming shipping plastics from PHB, as it is one of the most common ways that single-use plastics are used. Taking inspiration from this system, we recognized that some modifications can be made. Primarily, our project is aimed at enhancing the production of PHB through modifying C. necatar. Firstly, we are considering the idea of genetically engineering the bacterium with different genes, including the CSC gene, to yield greater PHB production. Additionally, we will introduce a medium of mixed acids. As many studies have shown, nutrient-deficient environments cause strains of C. necatar to favor the PHB cycle as a form of energy synthesis. We will also optimize the system by downsizing it to a commercial scale. Most carbon capture methods are tailored toward industrial use. Industrialized implementation overlooks the hundreds of office buildings, schools, and institutions within our city and country that contribute toward global warming emissions substantially, however. A commercial scale would give more environmental rights to groups that are often marginalized and do not hold as much power as larger industries often do. by providing individuals on a smaller scale with access to a tool that has the capability to both reduce carbon emissions and produce bioplastics, we would be developing an inclusive product. As a society, we have enjoyed the convenience that comes with single-use plastics. However, in this pursuit, we have inherently created a culture of disposability, where convenience has come at the expense of sustainability. As a society, we must educate our communities of the harmful effects of plastic and carbon pollution and involve them by implementing these solutions locally. We must take actions now to build toward a future that is sustainable and equitable for all. Biocapture, carbon pollution, plastic solution.